Hey everybody. So today we're going to talk about reflections. This is the second section of the third unit. So we talked about translations, which were shifts. Now we're going to talk about reflections, which are flips. Okay, so this is the second of the big three. All right, so we'll get right to it. A reflection is a transformation in which a pre-image is flipped via a line of reflection. This preserves congruency. Okay, so what does that mean? So basically, we're going to take a pre-image, we're going to flip it, and it's still going to be the same shape and same size. The important thing is you need a line of reflection. You cannot perform a reflection without a line of reflection. Okay, and the line of reflection determines the placement of the image in a reflection. All right. Now we have an example here. This is going to be tricky. These are a little hard to do. These are a little challenging to do freehand. So it's asking us to take this trapezoid and reflect it over this line. So no promises here. This is not going to be perfect. I'll tell you right now. I can already. Yeah. So essentially, what I need to do is draw the same shape but reflected, and it is not an easy task. I will not lie. Yeah, it's not easy to do. So the way I'm going to do it here, man, I always have a hard time. I always have a hard time doing these freehand. So I'll try the best I can and see how it comes out. Let's see. No, that's not good. That's not good. That's a little better. It's not quite as bad. I'm going to go this way. I'm going to go this way. So it's not great. Let's be honest. Let's be honest. This image is not great. I'll give that a 2 out of 10. All right, so this is the pre-image, and this is the image. We're flipping it, and it'll get better. It's only going to go up from here. You get the idea, though. It's flipping over. If I was to fold this along this line, it should be right where that is. Unfortunately, this is not. It's not great, but you get the idea, I think. The important thing is this: these vertices, these vertex points here, these should be equidistant from the line of reflection as the image. So this corresponding point, let's just call this A, and this would be A prime. This point should be equidistant from the line of reflection. So if I had a ruler, I could actually do this, but I forgot one. So anyway, same with this one. Let's say this was B prime. Oh, sorry, B, and this was B prime. This distance here from B to the line of reflection and the distance from B prime to the line of reflection, those two distances should be the same. And if I was able to do that, then I could connect those and no problems. But anyway, that's the idea. It's going to make more sense when we see when we do it with a grid, it's much, much, much simpler. Okay. When you're doing these, you want to use a pencil. I'm going to use colored pens just because it shows up better on camera. So that's why I'm using that. Okay, so so this is the first one. We're going to reflect it over the x-axis. So the x-axis is right here. This is the x-axis, right? So that is our line of reflection. It's going to reflect over that. So you can actually see this is going to flip, and it's actually going to fold upon itself because this pre-image is on both sides of the line of reflection. So we're going to use a blue pen. Now, I want to show you a little trick here. We're actually going to do this without even using the rule first, because you can actually kind of cheat. And I'm going to explain why I'm showing you how to cheat. You can count the distance. So R is 1 block from the line of reflection. So therefore, we're going to go the opposite direction, equidistant here. So R prime is 1 block from there. S is 4 blocks. So S prime is going to be 4 blocks. U is 0 blocks, so U prime is still there. It's going to be right on. If you have a point that is on the line of reflection, when you reflect it, it stays right there, right? because it's equidistant. So distance is 0. It'll be the same for the image point. T is 3, so 1, 2, 3. I counted 3, so T prime. Okay, now if I connect these, it should create a congruent figure, which it does. And you can tell, you can actually see I'm going to zoom in here so you can see a little better. Hold on a second, there we go. So you can actually see how it's folded in upon itself. If I was to fold this paper here, it would be identical, okay? And let's go ahead and get these coordinates. So 1, 2, 3, 4, 1, so it's going to be -4, +1. +1 here. And then S prime is -5, -4. Okay. And then T prime is going to be, let's see, -1, -3. And then U prime is going to be the same. Okay. I think I hear the heat in this building, in this room rather. It's the temperature today. Wow. It's like actually really warm in here. That's awesome. Anyway, so yeah, so there's the coordinates. Now you can actually kind of figure out this rule if you look carefully. You'll notice that the y value changed its sign and the x value remained unchanged. And that is what it should be. So what's going to happen is we're going to say it's x opposite y. We don't say negative y because that gives the inclination that it's always going to be negative. It's opposite, so the y value will change its sign. And that's it. So you can actually say to yourself, oh, okay, well, if I know it's reflected over the x-axis, I know all I need to do is change the sign of the y value, and those will give me the coordinates. And that's it. And the reason I showed you how to do it this way first, we're going to be doing reflections with lines that are not on the axes, and like just a perfectly vertical or horizontal line. And that's how you do those. Okay, so let's flip it over. And now we're going to reflect it over the y-axis. So let's go ahead and do the same thing. So this is our line of reflection. We're going to cheat, and again, for the same reason, because we're later going to have to graph reflections using non-axes lines. So let's count. So it's 1, so 1 is T prime. U1, so U prime is 1. R is 4, so we're going to go 4. So we're going to go 1, 2, 3, 4. R prime, and then S prime is 5, so 5 over here, S prime. And we're going to connect those. And yeah, there you go. So it's reflected. So let's go ahead and check these out. So 1, 0 for U, excuse me, for U 0, yeah, for U prime. T prime is going to be 1, 3. And I think you can already see what's happening here, what the rule is going to be. S prime will be 5, 4. And then R prime is going to be 4, -1. So you can see what happened here. The x value actually changed its sign. So it's going to be opposite x, y. So when you reflect over the y-axis, the x value changes signs. A really easy way to remember this is that you're going to change the sign of the opposite letter. So if you're reflecting over the x-axis, you change the y. If you're reflecting over the y-axis, you change the x. Pretty straightforward. Now we're going to reflect over the line y equals x, and that's what this line looks like. It's a line with a rate of change of 1, or m of 1, and it crosses the y-axis at 0 at the origin. So this is what the line looks like. Now you can even cheat with this. I'm going to show you how to cheat with this. So look, it's half a block, half a block. I'm going to say half a block, it's diagonal. So we're going diagonal 2, we're going to go diagonal 2. We're going to go diagonal 1.5, we're going to go diagonal 1.5. And how many is this? 1, 2, 3, 4.5. So half, 1, 2, 3, 4. So that's going to be our S prime. This is our R prime. This is our U prime, and this is our T prime. So let's go ahead and connect those. And there we go. So that actually forms a reflection. Now there is a rule for that, which you're going to see in a second. And it's actually much easier just to use a rule. I just think it's fun to do it that way sometimes. All right, so let's go ahead and write the coordinates here. So U prime is going to be 0, -1. T prime is going to be, let's see, 1, 2, 3, -1. I screwed that up the other day when I was doing that one. S prime is going to be 4, -5. And R prime is going to be -1, -4. So you can actually figure out this actual rule because you're just changing it. The x and y just flip. So y becomes the x becomes the y. Okay? All right, last one, well, last rule we're going to learn. Y equals -x. So this line of reflection is going this way. So it has a rate of change of -1, and it still has the y-intercept of 0, 0, which is the origin. So that's going this way. So let's go ahead and cheat again. So we're going to go one diagonal, one here. We're going to go half diagonal, half here. We're going to go half diagonal, half here. And we're going to go, ooh, what's this one? It's a tricky one. 1, 2.5. So half, 1, 2. Okay. So let's go ahead and label those. So S prime, this is R prime, this is T prime, and this is U prime. So when we connect these, it should form a congruent image. If you're graphing these and they're not congruent, you know you made a mistake also, just like in the translations. Okay. All right, let's go ahead and write the coordinates here. So U prime would be 0, 1. T prime would be negative 1, 2, 3, negative 3, 1. S prime would be negative 4, 5. And R prime would be 1, 4. Okay, so you can tell we changed them, we flipped them, and we changed their signs. So XY becomes opposite Y, opposite X. All right, so those are the 4 rules. You need to know those. You need to know the x-axis rule. Let me zoom out a little bit. And you need to know the y-axis rule, the y equals x rule, and the y equals negative x rule. So there's 4 rules to know, okay? All right, so the next part of this, and am I going to be finished this in time? I think I will. I'm trying to finish this before third period starts. So now what we need to do is determine the line of reflection. So there's a few ways to do this. You can do it visually, or you can do it with the coordinates. So we're going to do it 2 ways. I'm going to look at it, first of all, and I'm going to rotate my paper in a way that I can see the line of reflection going up and down. So if I look at it this way, I can tell this is the line of reflection. And you'll notice the trick is literally rotating the paper. It's that simple. It's a really nice little way of doing it. So if I rotate the paper, I can tell this is the line of reflection. And that line of reflection is y equals x. So I already know. But before that, we can do it another way. Let's start with a pre-image point. So this is going to be 3, negative 1. So D is 3, negative 1. And we're going to become D prime. And D prime is negative 1, positive 3. Okay, so we took our variables and we flipped them. If we go back to our rule here, if we just flip them, we know that is this rule, which is y equals x, as we said. So the line of reflection is y equals x. And let's just double check that. Let's draw y equals x and make sure it makes sense. And sure enough, it does. So 2 ways to do this. You can literally rotate the paper and look at it that way, and you can use the points. So I think it's important to be able to use both. All right, let's do that again here. So we have a pre-image and an image. I'm going to rotate that. And lo and behold, I think it's going to be the x-axis. Let's find out. So let's do m. So m is 4, negative 1. M prime is 4, positive 1. Oh, why did I put a negative sign there? So the y value changed. So if we go back to our rule here, the y value changes, nothing else changes. That is the x-axis. So the x-axis is the line of reflection. And let's highlight that to make sure it makes sense. And sure enough, it does. Okay? So that is how you identify the line of reflection given the graph. Now here, they're going to go ahead and give us the coordinates. So it actually doesn't give us the option of using the graph. So that's fine. So we're going to say, all right, let's go h to h prime. So h is going to be negative 5. I don't like how they line this up though. You can't even, if it was above each other, I guess it makes sense. But the way they drew it is kind of confusing. And then h prime is going to be negative 3, 5. So we changed the variables and we changed their signs. And if you remember, that should be the line of reflection is y equals y equals negative x. So y equals negative x. And here, yeah, see, they don't line them up. They try to trick you into thinking these two go together. So s and s prime. So s is going to be negative 5, 2. And s prime is going to be 5, 2. So again, we don't change the position, but the x value changed. So if the x value changed, I believe that's going to be the y-axis. Let's double check. Yes, the x changes in the y-axis. So that's going to be the y-axis here. Okay. Now we just have to write the coordinates to reflect over the y-axis. Let's go to our rule. We're reflecting over the y-axis, therefore the x changes signs. So we're just going to change the x value. So negative 2, negative 5. And then s prime is going to be, you know what, might as well write the rule. Not a bad idea, right? So opposite x, y. Good idea just to reinforce that. Negative 2, negative 2. And then t prime will be negative 3, negative 3. Okay. Over here, y equals x, so that means we're going to go yx. We're going to change it, so we're going to write our rule here, so we don't get confused. Yeah, so b prime. How is that a b? Jeez. Okay, let's try that again. So 0, negative 2. C prime is going to become 1, negative 2. D prime is going to be 1, 3. And E prime will become negative 3, 1. Okay. Graph the image. Here we go. Reflect over the x-axis. So I'm going to highlight the line of reflection. There's our x-axis. And we know that the y values are going to change. So I'm going to go ahead and write the coordinates here. So R is going to be 0, 3. S is going to be 4, 1. And Q is going to be 0, negative 1. So I know the x-axis means we're going to go x, comma, opposite y, so the y value changes signs. So the R prime, we're just going to change the y value. So 0, negative 3. And S prime is going to be 4, negative 1. And Q prime is going to be 0, positive 1. So let's go ahead and graph that in blue, I guess. So 0, negative 3 is 1, 2, 3. 4, negative 1 is right here, and then 0, 1 is here. So let's go ahead and graph this. That's R prime, that's Q prime, and this is S prime. Okay, there we go. Last one, y equals negative x, so that's going to be, well, we change them, positioning and their signs, so it's going to be opposite y, opposite x. So u is going to be negative 4 or 5. T is going to be negative 3, 0. And V is going to be negative 5, 2. So we're going to change them and change their signs. So flip them and change their signs, I should say. So U prime is going to become negative 5, 4. T prime is going to become 0, 3. And then V prime is going to become negative 2, positive 5. So let's go ahead and draw the line of reflection. So y equals negative x is actually going to look like this. And the reason we're drawing a line of reflection is so when we graph it, we can actually tell if it makes sense. So negative 5, 4 is going to be down, sorry, negative 5, 4 is actually going to be, let's see, negative 5, 4. Why am I having a hard time with this? Okay, it's right here. I don't know why I had a hard time with that. That took me a while. Okay. U prime, and then T prime is going to be 0, 3. And then V prime is going to be negative 2, 5. Sorry, V rather. V prime. And if we draw it, yeah, that looks about right. Looks like it reflects properly. There we go. Okay, so that's a lot of stuff. So if you're confused about that, let me know. The last part is going to be symmetry. So this is self-explanatory. Now, lines of symmetry, you can see it with an object. Here's a line of symmetry. Okay. Here's a line of symmetry. Here's another line of symmetry. Because you're creating two congruent pieces. Here's a line of symmetry. I'll let you do the rest. Have fun with these. Now, point symmetry means you can actually rotate the object, and it would have symmetry if you rotate it. This would not work. You'd have to rotate this a full 100. You'd have to rotate this a full 360 degrees. But an object where it would have rotational symmetry is if you took this shape, this N, right, and you were to rotate it 180 degrees. Guess what? You have the same shape. So that would be considered to have point symmetry. I'll let you figure out the rest of these because they're kind of fun to do on your own. Okay. All right. So that concludes the notes for 3, section 2. I hope that clarifies it. Before I leave today, I'm going to go over some examples because the homework is pretty intense. Now, you're going to have 2 days to do it, so I'll just show you real quick. I'm not going to go into it just yet. There are some problems where you have to reflect the points. There's some problems where you have to write the rules. And then there's some other problems where you actually are going to do multiple transformations. You're going to do a reflection and you're going to do a translation. So we'll get to those later. I'm going to make another video for those, okay? All right, thanks for watching, guys. Let me know if you have any questions.